Well, Multimedia Science is back with another software application. This time it's the Center of Mass tutorial. There are several ways that you could use this piece of software as a physics teacher. First of all, you could use it as a lecture aid, showing it on a smartboard or a projection screen in front of the classroom. Or you could have your students work through the various tutorials, simulations, and drills on their own in a computer lab, or again, as a class in front of the classroom. So let's start the software. You can see that there are a number of screens that either are definition screens or tutorial screens where they talk about the center of mass and what the definition is. There are demonstrations which illustrate how to find the center of mass depending on whether it's one-dimensional, two-dimensional, or three-dimensional. After each of the demonstrations, there's a drill to see whether the students can actually do the calculations and understand the concepts. There are some special examples like the Earth-Moon problem. There's a quick game where they have to figure out an equation by sort of playing a little puzzle. And as you go through each of these items, a little check mark will be placed next to them to show that you have indeed gone through and looked at that particular area, so you can keep track of where you're at. Also, when you finish the drills, there are scores that show you how you've done, and then at the end there's a final score. So of the students who are working in the computer lab, you would keep track of the progress as you worked and facilitated with them. Here's a brief overview that's available as a Word document, so you can just see the list of screens and briefly what they are, and then talks about some ideas on how you might go about using the various drills and demonstrations. So let's pick out a few screens to look at. I don't think we would want to go through every single one of them, but let's first of all look at what the definition of the center of mass is. Pretty simple concept. Brief little simulation just to make sure that students understand the idea. Here we have a demonstration of a one-dimensional situation where you can change the mass of the balls and the two masses that are involved, and you can see exactly how that affects the center of mass, which is the purple line in the middle. You can make that marker invisible and then say, well, gee, if we make the mass such and such, where would the marker show up? And then see whether or not the students have calculated it correctly. Right after that, we have a tutorial where it talks about what are the variables that are involved in figuring out the center of mass. And they have to choose these until they get the answer correct. And of course, it's unfortunately a lot of variables. So this has them start to think about that. There's then some discussion about exactly, again, what is the center of mass, and continues to go through defining the variables that are involved. There's a drill where they're given a problem with the mass and the location on a, I guess you could say, number line, and then they have to choose, do the calculations and choose, and then check their answer. So this is a nice little practice. In each case, there is a help screen that talks about exactly how to go about the calculations, how to run the simulation, and so on. There's an Earth-Moon simulation where it illustrates exactly where the center of mass would be for the Earth-Moon system. And as you can see, it's actually inside of the Earth's radius or diameter. It looks at what happens if you take a 2D object and you take a hole, you take a piece out of it. And again, you can fool around with some of the variables and see exactly where the center of mass ends up. There's then a drill where students have to calculate the answer. We have a similar situation where we look at the two-dimensional situation where it gets a lot more complicated. So you've got more complicated equations to deal with. And again, you've got a simulation where you can change the variables and see exactly what happens to the center of mass. You can also make it invisible and have students calculate out the answer. And then, of course, there's the two-object drill where students have to put exactly what they think the center of mass will be in both the X and the Y direction and check their answer. That was kind of an easy example. Obviously, it's not going to be that easy every time. There's a 3D equation game where students have to solve the puzzle to figure out what the 3D equation is. Calculating it out is pretty complex. You may or may not want to actually go through that. And then it ends with a demonstration or a simulation of a 3D situation where now we have a sphere embedded in another sphere with different densities, and you can vary the variables, change the variables, and see exactly what changes to the center of mass. So it's a fairly complete package of information and simulations for you to work through. Center of mass, 1D and 2D, especially calculations with your students, and extend to 3D if that's, if they have the ability to do that. If you're interested in the tutorial, please go to the Multimedia Science Teachers Pay Teachers site. This is the URL, and type in Center of Mass Tutorial and maybe add Multimedia Science. Enjoy.